This is the introduction to section 3.3, part 1, talking about proving parallel lines. And two objectives here. We're going to prove theorems about parallel lines. And we're going to use properties of parallel lines to find angle measures as well. Okay, so you'll notice as you look at your note sheet and you see three new theorems and a postulate, you'll notice they're very, very similar, and you see the word converse. Remember, the converse of a conditional is if we flip the hypothesis and conclusion. So before we were talking about if the lines are parallel, then corresponding angles are congruent. Okay, now we're going to flip that around. If corresponding angles are congruent, then the lines are parallel. So now we're trying to find ways to prove lines parallel. Okay, so first one here is the converse of the corresponding angles postulate. It says if two lines form corresponding angles that are congruent, then the lines are parallel. Okay, and I've put down in here two things that are going to be important for you. One, you need to be able to identify the parallel lines, and two, you need to be able to identify the transversal. Okay, the transversal is going to turn out to be very important here. That's why we've been practicing that. So the statement I put over here on the right box is if corresponding angles are congruent, then L is parallel to M and N is the transversal. Okay. Same thing with the converse of the alternate interior angles theorem. It says if two lines in a transversal form alternate interior angles that are congruent, then the two lines are parallel. Again, you need to be able to identify what is the transversal. In this picture, the transversal is N, and you have alternate interior angles that are congruent. That's what the markings are there for. So, if alternate interior angles are congruent, then L is parallel to M. And then I always put in here, and N is the transversal, so that way I know what the transversal is. Okay? So, Theorem 3.5. Theorem 3.5 talks about the converse of the same side interior angles theorem. So it says if two lines on a transversal form same side interior angles that are supplementary, then the two lines are parallel. So here, angles 3 and 6, they're saying add up to be 180. If that's true, then that means that L and M are parallel. So if same side interior angles are supplementary, then L is parallel to M and N is the transversal. Okay, and then the final one is now we're going to take and say if two lines in the transversal form alternate exterior angles that are congruent, then the two lines are parallel. So, here in this picture, you see that 1 and 7 are alternate exterior. They've got the markings so that they're congruent. If alternate exterior angles are congruent, then L is parallel to M. Okay? So, these are the four ways to prove lines parallel. These four ways. That's very important. You're probably going to want to write that down in your notes. These are the four ways to prove that two lines are parallel. Okay, now is where we're going to take and actually put this to the test. So it says identifying parallel lines. And you'll notice the picture up top. We've got lines L, M, A, and B. And it says which lines are parallel if angle 7 or angle 6 is congruent to angle 7, and justify your answer. Okay, so what I always usually do is I always usually circle them. So there's 7 and there's 6. First of all, what type of angles are these? That's what you want to identify first. What type of angles are these? Well, 6 and 7 are corresponding angles. So 6 and 7 are corresponding angles, and I know that corresponding angles are congruent. The next thing I want to do is I want to identify the transversal. Okay. On the transversal, remember the transversal includes both lines, or both angles, I'm sorry. So 6 and 7 are the angles, and they're both on line B. So B is the transversal here. Okay? If B is the transversal, then I can say now that L is parallel to M by corresponding angles being congruent. Okay, so hit pause on your video and take a look at this second problem and see if you can answer the second problem, and then check back and see if you got it correct. Okay, now that we've come back, you should have answered this one. Which lines are parallel if angle 1 and angle 2 are congruent to each other? Justify your answer. So, as you look at this example, angle 1 and angle 2 are congruent to each other, so I'm going to circle angle 1 here, angle 2 here. Those are the two angles. Okay, again, what type of angles are those? Those are corresponding angles. And we got to figure out the transversal. So angle 1 and angle 2 are both on line M, which means that A is then parallel to B because corresponding angles are congruent. Okay, so that's kind of gives you an example, two examples there of how to identify which lines are parallel. Right. Okay, now let's take a look over here to the right, top right. It says, what's the value of x for which A is parallel to B? Well, if A and B are parallel, we've got to look at this and figure out what type of angles we have first of all. Well, if A and B are parallel, these are same side interior angles. So if they're same side interior, they have to add up to be 180 degrees. Okay, so if they add up to 180 degrees, I solve this here. This is 2x plus 120 equals 180. If I subtract 120, this becomes 60, and x equals 30. Okay, now, in this case, x is going to equal 30. They're parallel. A is parallel to B by what I call same side interiors are supplementary. Okay, that's the reason that those two lines are parallel. All right. Okay, so again, what I want you to do now is pause the video and take a look at this problem here. What is the value of W for which C would be parallel to D? And then come and check back to see if you got the correct answer. Okay, now that you've paused the video, you've went through and you have completed your answer, let's take a look at this. Now, these two angles right here are, first of all, you got to figure out what type of angles they are. Well, they're corresponding, so they're in the same position. So if they're corresponding, they're going to have to be equal to each other in order to be parallel, C and D. So when I solve this, 3W equals 57, and in this case, W is going to equal 19. Okay, so the value of 19 is going to make these two lines parallel, and C would be parallel to D by corresponding angles being congruent. Okay, all right, so you've been able to check now. You should be able to ask a couple questions. Make sure you complete your WSQ. This is the end of 3.3, Part 1.